What's up, Internet? This is Josh, and welcome back to this tutorial series. Today we're going to evolve the game concept idea that we came up with last time. We came up with this concept for this basic farming game. We're going to develop this plan a little bit further to kind of figure out how we're actually going to build this concept. We're going to grab our actual game engine, and we're going to start building. So, to begin with, we have to grab our actual game engine. And we decided last time that we were going to use Unity for this project. So we just gotta go to the Unity website. At some point in this process, you are going to have to sign up for a free Unity account just using your email. But like I said, it's free, it's easy. We're just going to download the Unity hub here. Give that an install, let it do its thing. And then once the actual Unity hub is installed, this is what we're going to use to get the actual editor. So if you don't have a editor already installed, then you can just kind of grab whatever. This is recommending Unity version 6.1, and for our purposes, we can just grab whatever is the most recent. I'm already signed in, I guess it looks like. So if you haven't already created a Unity account, you will have to do that in order to get to this point. And it's going to prompt you to activate a personal license, and for our purposes, that's going to be just fine. So yeah, once we have this hub installed, we can see that it's already downloading Unity version 6.1 for us. And so at the moment, we're basically just waiting for that. So this is a good time for us to return to our concept for this farming game and kind of figuring out how we're actually going to build it, what we're going to need, and what our approach is going to be for our kind of actually bringing this project to life. So let's start writing it out a little bit. We already know that we are going to need our player, and the player is obviously going to need to be able to move around. We kind of talked a little bit about the tools and things like that. Ultimately the player is going to just touch a tool and automatically pick it up. So the tool needs to have a way of knowing when there's well, we'll talk about it a little bit more, but we need a way to determine when the player touches a tool, when the tool touches a player, either way you want to look at it, which we can kind of just call basic collision. The idea is we're not restricting the player's movements at all, but we need to know when the two overlap in order to process what the actual interaction is. And so the player needs a way to be able to hold tools based on when this collision happens. And then what does the player do with those tools? Well, we know that we're going to have certain spots where the player can plant plants, and so we need kind of I'm going to call it like a plant location. Effectively, a spot where the player can plant things and where the plants are then therefore going to grow. So this is also going to need some kind of collision in order to detect when the player is interacting with the plant location. So if the player has a seed in their hand and they walk over the plant location, we say the player can plant the seed. And so we can also say that, obviously based on that, if the player doesn't have a seed in their hand, if they have like a watering can in their hand, then that's a different interaction. So we're going to need to be able to process interactions based on the player's tool. And then after that, one of the main things that this plant location is going to have to do is going to be actually maintaining the lifetime of the plant. Potentially there's other ways to do that part as well. But at this point, I think we need to start thinking a little bit about what are our actual mechanics. What is kind of like the life cycle of a plant? What is the kind of, what are we asking the player to do in order to kind of like progress the plant forward and like advance towards their victory condition? So ultimately, we want the player to plant the seed, we want the player to water the seed, and then we want the player to harvest the seed. So ultimately, we can say that probably watering and harvesting require separate tools, and maybe each seed in itself is a different tool in a way in its own. So I guess the vision that I have in my mind is that when you plant the plants, there's like a little water droplet icon, and periodically you just have to water the plant, and then after a certain amount of waterings, the plant is ready to harvest, and then you grab a different tool, interact with the plant, and then that's when the harvesting happens. And so we can maybe just call this plant life cycle. since a lot of the actual interactions and stuff like that are kind of encompassed by this part of our plan here. And then beyond that, when the player actually does harvest a plant, we know that they're going to need a way to acquire score, and so we're going to need a way to track the score. And then we can call this a separate element, but we also need a way to actually display the score to the player. And we should probably also say that based on the player's score is how we determine when victory has actually occurred. And so, based on this, we can say this is a pretty good plan of like what we're actually going to need to build in order to make our actual game. And so based on this plan, I've already prepared some of the assets that we're going to need in order to make this game. We talked a little bit last time about how, depending on what your personal goals are, you should consider making your own assets. But if, your art skills are maybe not necessarily something you're looking to improve at, it's pretty easy to just kind of find freely available assets out there on the internet. But I've taken some of the assets that I had available to me already just sitting around, and I've arranged them basically in sprite sheets. And so we can kind of see some of the plant states that we're planning to have for our seeds. So, we can say that, potentially we have three different types of plants that we want to plant, and then 3 stages for each plant. So, when you plant it, when it's grown a little bit, and then when it's, perhaps once grown a little bit more. We also have a state for when the plant location is actually empty and is kind of waiting to accept a seed. And so with all these prepared, once the actual Unity project is ready and installed and good to go, then we can just kind of plop those assets into the project, and we should be good to start building. And just like that, while we've been making our preparations in the background, Unity Hub has finished installing Unity version 6.1 for us, and so we are ready to start our first project. So we just need to go over to the Projects tab, click on New Project, and this is where we're gonna kind of start making some of our first decisions. So for our case, we're going to be making a 2D game, and this is kind of important to select for Unity because, one of the things we talked about in the initial episode of this series is the fact that Unity is a game engine that has a lot of bloat. And so if we choose something like 3D or one of these sample projects, there's going to be a lot of stuff in the project that it creates for us that we don't need. So we want to make sure that we're making a 2D project. And then, just give it a name. And click create, and it'll kind of handle the rest of it for you.
6 minutes later.
Just like that, we're in Unity. So, that initial opening of the project for the first time might take you a little while. This is one of the downsides to, like I said, the bloat of Unity is that some of these things take a lot longer than if you were to use an engine like Godot. But all the same, here we are, and we're finally ready to actually start building something. Basically, the way that Unity works is that everything in your game is either a scene or a game object. So, scenes are basically, the way that a game is broken up and organized into different areas or different types of content and stuff like that. So, you can kind of think of this as like different levels. So, level 1 might be one scene, level 2 might be a different scene. And you can kind of see that this is, at the moment, just called sample scene. So, if we were to save this Unity game, it would want us to save a scene. And right now it's just using sample scene. So if we were to reload this project after closing Unity, this is what we would want to open, is the sample scene. And this is going to open, unless you want to open a different level. If you want to open a different level, you would click on the scene file for that level. And then inside of each scene are game objects. And these are kind of like the main things we're going to be dealing with. And these are kind of like all the different parts of the game that make it work. We're not going to worry about a lot of that too much for this initial project. We're just going to use the default scene. But before we can get too far, we do need to grab our assets. So we can see here at the bottom, this is our project content browser, or whatever you want to call it. But this is all the files associated with our project. So right now we're just in the assets folder, And generally, there's a whole bunch of different ways to organize your project depending on the structure of the project and, you know, all this, the size of your team and all this kind of stuff. But a reasonably decent way of doing it is just having, you know, different folders for different type of assets. So, you know, we looked a little bit at these images before, but we can just kind of drag and drop them in here. And Unity will import them for us. Now we can kind of click on them and get a little bit of a preview of what we're looking at. On the right side here, this is our inspector, and this kind of gives us information about whatever it is that we're currently clicked on. And so we can see that for these sprite sheets that we talked a little bit about earlier, it's kind of looked at these assets and said each one of these is a different sprite, and it's automatically kind of like separated these out for us so that we can use each frame individually. But we're going to talk a little bit more about these later. For now, we're ready to basically just start building, so let's do it. I think the first thing we should look at, our first goal should be just getting a background for a project, because, you know, right now we're just looking at this blue square and, you know, it's not the most inspiring thing ever. So in order to actually create our background, like I said, everything in Unity is a game object. So we need to create some game objects that have the functionality of drawing to the screen effectively. So we can just create an empty game object, and this is, you know, this is our game object. And by default, there isn't really a whole lot to it. All game objects really have by default is a transform, which is effectively their position in space, where they are in the world. So if we come to our scene view, this kind of gives us a more like debuggy view of what we're currently is in our scene. We can see that our game object kind of just lives here in the middle. It doesn't really do anything. You know, we can move it around, but at the moment, like, it doesn't have any functionality. It doesn't do anything. It just kind of literally it just exists. But what we want is for, well, I mean, we're trying to draw our background, right? So let's rename this to background. And in order to get it to display, specifically, we're trying to draw a 2D image. And in order to do this, we need to add a renderer to it. And we can see that there's a whole bunch of different types of renders in Unity. And this is one of those things where you're going back to the bloat. Because Unity is effectively a 3D program first and it has kind of like 2D functions tacked onto it, there's a whole bunch of different types of functionality that Unity gives us access to. But for 2D stuff, we're going for sprites. I think the way it works is that generally 2D has this kind of like purpley type icon associated with it. So now we see that when we added the sprite renderer, we have this kind of like new box with all this stuff in it. And the way that Unity effectively works is that, like I said, by default, game objects only really have a position. But in order to make a game object do more, we're adding functionality to the game object. We add components. And the component is basically responsible for doing one specific job. So in this case, what we're trying to do is just draw to the screen. We have our grass image here, and we want to draw that on the screen. And, you know, typically 2D sprite, you know, pixel images are usually referred to as sprites. We can see that in the editor here, it's imported. It's a texture type sprite. So this is what we're trying to draw, is this sprite. So we need to use the sprite renderer, and it has a little selection area here. And this is basically, you know, what are we trying to draw? We click the little icon here. We can see all of the things that are in our project. And we can. This is basically, you know, what sprites are available for us to draw, and we can just choose our grass. And there it is. Our grass is now being drawn to the screen. This is the sprite renderer doing its job. But now, obviously, this little rectangle of grass is very small. These assets that I grabbed are all 32 by 32 pixels, effectively, is the way they're set up. You know, generally, when you're making a pixel-based game, you want to try and use assets that all have the same, like, pixel size. So all these assets are designed to be 32 by 32 pixels. You know, 32 wide by 32 high. So effectively what this is doing at the moment is it's just drawing 32 by 32 pixels in the middle of our 1920 by 1080 screen. So in order to make things it a little bit bigger, there's a bunch of things that we can do. The easiest one is we just increase its scale by a whole bunch. And that literally just stretches it out. And, you know, this doesn't look the greatest, but it's an option that we have available to us. One of the things that I think is important to kind of keep in mind, you know, from the very beginning as we approach game development is that whatever you're trying to achieve, there's almost always, you know, an infinite number of ways that you can actually accomplish that. And, you know, some of them are going to be better than others, but you have to kind of weigh what the kind of like strengths and weaknesses of each approach is. So for our purposes, just scaling up the grass until it's, you know, stretched out and like this looks awful, but that's something that took like 3 seconds to do. And so that's something that we could consider, but maybe that's a little bit too far. So a good approach I find is that generally you just kind of scale it up a little bit. Usually a 32 by 32 pixel square is so small that you kind of can't even see it very much anyways, so blowing it up a little bit so that you can see some of the details I think works out pretty decently in kind of like HD resolution displays. And then effectively we're going to tile it. You know, if you look at most old games, especially on things like, you know, the Nintendo and the Super Nintendo, stuff like that, pretty much everything in those days were done by taking these kind of like square tiles and then just kind of repeating them and kind of drawing levels and things like that way. So, you know, Unity does have tile tools available to us. We could make a tile map, and that's like a whole system that is that Unity has ready for us. But for today, we're going to try and keep things a little bit more simple. But all that we're going to do, we're just going to duplicate this guy. We're going to come in here where we can kind of see things a little bit better. We're just going to move him. And this is where kind of some of the quirks of Unity and the way it handles 2D starts to come in, because we know that our source tile is 32 by 32 pixels, and so like kind of figuring out where to position this becomes a little bit strange, because we can see that this is at position 1.29, which is a little bit strange. Effectively, everything that Unity does, it tries to kind of convert into Unity units. We can see here that we have this pixel per unit setting, which is set to 100. And so it's effectively kind of saying, try to fit 100 real-world pixels into one Unity unit, which, you know, it probably doesn't make a whole lot of sense, but effectively, you know, instead of saying this tile is at position 32, which if we zoom out, we can see this is like way off the screen here. It's more like we're saying it's at position 0.32. And then, you know, we can see this is overlapped a little bit because these are both at scale 4. So basically we can just even put that equation right in here and say 0 times 4. So we're basically saying we're trying to position at 128 pixels over, because it's 32 times 4, and then the pixels per what's it called? The pixels per unit setting is 100, so instead of 128 pixels, it's 1.28 pixels. You know, the math is a little confusing, but we're not gonna have to worry about that too much. Effectively, what we're just gonna do is kind of repeat that process. And now that we're at 0.128, thankfully we can just type equations into here. So we can just say 0.128 times 2. Okay, it again. 1.28 times 3. And like that, we've just kind of now hit this covered over to the right side of the screen. The way that Unity's coordinate system works is that 0, 0 is in the middle, and then, you know, positive x goes in this direction, negative x goes in this direction. But what we can also do now is take all these tiles that we just made, duplicate those, and then make the negative of each, or the x coordinate of each of these a negative. And then from there, you know, now we have one row, and we can kind of just repeat the process for the Y. But we would want to, a good way of doing this first is parent this to a new object. This is basically just an empty game object that we're calling a row, which has all these children. So now the idea is we can duplicate this row and do the same thing on the Y. Ah, I see. This initial one isn't in here. So now when we duplicate this row, go 1.28, 1.28 times 2. And then once again, just do the same thing on the negative. And we have our background. And now because it's not so stretched out, we can kind of have, it doesn't look quite so ugly. We can kind of see it looks a little bit more like you can see blades of grass rather than just being a giant blurry mess of like, you know, random green colors all over the place. And now, like we said, this is definitely not the best way of doing things. There's, like I mentioned earlier, there's tools that exist already for us that kind of gives us this functionality, so we don't need to recreate it. But for someone who's just learning, sometimes it's easier to just kind of like take a simpler approach that kind of actually does work in your brain, that you do understand, and kind of see how you can play around with it, what the strengths and weaknesses of it are. And for a project that's so small in scope like ours, where we know that we're never going to leave this one particular screen, it's not at an end of the world to kind of take a hacky approach like this, where we're just kind of like, it wouldn't work in other scenarios, but it does for what we're doing right now. So, yay, whoop-dee, huzzah, we managed to make a background for our game. Now when we click play, it's not just a blue background, it's a green background. We've improved, we've made a lot of progress so far. Okay, well, if we want to make this an actual game, then I guess we need our player. We should start thinking about how making our little character move around. And so how do we approach that? Well, what we need for these background elements are very basic. They're all we have is a sprite renderer, as just drawing the image to the screen, and that's all that they need to do. But our player character is a lot more complex. We can see that even, you know, the image that we're trying to use, this grass tile is just, you know, it's 32 by 32 squares of grass, whereas our farmer character has all these different assets, these different directions, and all this kind of stuff baked into it. So in order to set up our player character is going to be a little bit more complex, and that's where we kind of start using the component system in order to start adding functionality to the player based on what we would need them to do. So to start off, we can just create a game object and call this our player. And, you know, let's just start from the same place. We've got our sprite renderer. So what are we trying to draw? We want to draw our farmer, and similar to the grass, you know, make everything roughly the same size. Well, there's our farmer. Brilliant. You know, he can't really move around or anything yet, but he's there. And at the moment, this game object for our player is basically working exactly the same as the ones for the grass in the background. All it's doing is just drawing the image, but with one subtle difference. Why is the farmer facing to the right? Well, if we come back into our sprite sheet here, you can see this is just the first kind of sprite within the sprite sheet. What we really want is this one, at least at the moment. What we could do is just come into our player here and choose specifically that sprite. If we click the little arrow on the side here, we can get the individual ones within it. We can just say, I want this one specifically. Oh, can you not do that? What happened? Ah, is he... Interesting, okay. I'm not sure why that made him go behind, but this is where we start kind of getting into the fact that Unity is effectively a 3D engine that is kind of made to work for 2D. So, you know, if we go into the scene view and click on 2D here, we can see how our game is effectively 3D, but just kind of shown in 2D. So what happened there was the Z position of our sprite was behind the grass. And so we just had to bring it forward a little bit, which is towards the camera, putting it in front of the grass makes we need to put the Z on the negative side, whereas further back away is on the positive side. But at the moment, let's just say our player is at -1. And we can see, you know, here's the camera here. If we're looking in 3D space, the negative is towards the camera and positive is away from the camera. But anyways, okay, so now we've got our farmer facing the right direction at least. But obviously, we need him to do a little bit more than that. So I think a good first goal is let's get him moving around a little bit. And in order to do that, we're going to need to start writing a little bit of code. So what we're doing at this point is we basically want to make our own components, similar to how there's SpriteRenderer and all these other components that Unity gives us by default. We can also write our own custom code that gives us custom functionality. And so we can add a scripts folder just to have all of our code in one place. And what we want to do is add a new script to the player. We'll call it player input controller. Just save this in our scripts folder that we just made. And we can open that up. I'm set up so that I'm using whatever random version of Visual Studio. I think by default there might be some version of mono-develop that Unity ships with. I'm not sure if that's even still true, but ultimately you can set up whatever code editor that you want in the preferences. I think it's just yeah, right here. You just search for editor. It's just you can just set it up in here, but ultimately it doesn't matter too much. So here we have the script that we just made. You can see it's called input controller, just like the component that is now on our player here. And so this is kind of where we start defining like what is an input controller and what functionality are we adding to the game object when we add an input controller to it. Similar to how when we add a sprite renderer, that's giving the game object the ability to draw on the screen. We want to give the player the ability to listen to what buttons the player is pressing, and then move around depending on if the correct buttons are pressed. And again, there's a whole bunch of different ways to do this. And the way that we're going to take for this project is not necessarily the best or most advanced way. But what we're going to effectively do is we're going to use the update function of this input controller that we just attached to the player. The way update works is, like the comment here says, update is called once per frame. And what that means is that Unity is going to attempt to call this block of code as much as 60 times per second or whatever the frame rate of your game is. So if we were to put in something like yo, and then come over back to Unity, you can see it outputting yo constantly. You can see the number of messages going up, 600, 700, 800, because 60 times every single second it's shouting yo at us because of the code that we wrote here in our update function. And so this is where we're going to check for the inputs that we want. And the way that we do that is effectively by asking Unity, because Unity knows what buttons you're pressing. And so if you ask it, it'll just tell you. So we're going to use what's called an if statement. Idea here is we're going to write a little condition inside of these brackets, and then if it's true, whatever's in between these curly braces will happen. So input dot get key is what we're looking for, and effectively this is going to be saying, like, if we look at the tooltip here, that's when we hover over it, it says returns true while the user holds down the key identified by the key enum parameter. So basically what this is saying is whatever we put inside these braces next to get key is going to be the button that it's looking for. So the way that Unity determines what key is which is using a key code. And so we can kind of just look through, and this is looking for just any button on the mouse, any game pads, the keyboard, anything. And then if that button is actually being pressed, this section of the code will return true. So if we say W, then this is specifically looking for W. And if we run that, get some issues. Now, this is one of those things where, like I mentioned before, when you're approaching game development, there's always kind of like any number of ways you can do it, and some of them are going to be better than others. And so what we're getting an error here, effectively because what we're trying to do is this input.getKey is using the old input system within Unity. So there's a new input system which is much better and much more modern, but it's also much more complex. And so for the sake of this particular tutorial, we're going to just try and use the old input system, but unfortunately it's going to give us some errors, and so there's some stuff that we need to fix first. So to turn it off, we just have to go into project settings here. If we search for input, I think it's under player. Here we go, active input handling. We want to use the old input system. I think, yeah, that requires a restart.
Why would you do this?
So that on its own should allow us to actually use the new input or the old input system. But then the other thing we want to do is if we go into Window, Package Manager, wait for this list to refresh. This is all the things, all the functionality that we're asking Unity to load for us. So you can see this is why we chose 2D project at the start. We can see that a lot of the there isn't anything here about like 3D and stuff like that. Even though Unity is ultimately a 3D engine under the surface, it's trying to not load as much of the 3D stuff as possible because we asked it not to, because we're making a 2D game. So we're just looking for the input system here. I want to remove the old input system. And I guess this requires another restart? That's unfortunate.
Please, not again.
And now that the actual package for the new input system is removed, it also shouldn't complain at us about trying to like re-enable the backends or whatever the message says. But now if we click run, we can see that by default, nothing happens. If we hold W, it starts saying W is held, and we can use the old input system without any errors. But obviously we want our character to move around the screen and not just put a bunch of random nonsense in the debug console. So in order to achieve that, basically we just want to copy and paste this a few times, and we can say instead of W, this one is A. Instead of W, this one is S. Instead of W, this one is D. We have a W, A, S, and D. We can say W is up, A left, S is down, D is right. And with this kind of gives us the full like input detection that we need. Left, right, up, down. Now in order to actually move this guy, what we're actually doing is we're looking at the transform component that's on our player, and we're trying to move the position value. We can see that if we move the X in the negative direction, he moves to the left, and if we move the X in the positive, he moves to the right. And similarly with the Y, negative Y goes down, positive Y goes up. So effectively what we're trying to do here is something like, if we were just trying to move the position of the Y, if we're trying to go up, which is what the Y does, we're trying to go positive. So, we can say something like that. And similarly down, let's put these two next to each other, up, down, then left and right. Position is Y, we can say we're moving in the negative direction, so then minus. And then similarly for left and right, it's position, except we're doing X. And moving negative X, minus equals 1 moves us left, whereas moving positive plus equals 1 moves us right. So left is the A and right is the D. And also say left, right, up, down. Hopefully that would be obvious just from looking at the code, but if it's not, you can add a little comment, and this doesn't change the way that the code actually functions, it just makes it a little bit more readable for us. However, if we look at this, we can see this underlined in red. And this is because, for whatever reason, the way that Unity works under the hood, this position, transform top position, is not something that we can set directly. We can't just say change just the X. But what we can do is set it to a new value. So if we say vector2.0, we can see that this works because we're basically just setting it to 0, 0. So vector2.0 is basically like saying 0x, 0y. Similarly, if we said vector3.0, that's just adding the z dimension, and it'd be like this. So this code here would basically just set our character to the middle of the screen every frame. But what we're trying to do is actually increase or decrease the player's position depending on what button is being pressed. So the approach we want to take here is basically we need a way of storing that value, modifying it, and then setting the eventual value of the position here. So what we can do is vector3 new position. Basically just taking this code down here and moving it up here. And now, instead of setting it directly down here, we can set it to the value of this variable. And so, because this is a value that's like held in memory, we can change this value before we use it down here. So the idea is, in each of these little code blocks, instead of setting the direction of our transform component directly, we're going to change the value of our new position, and then that's what we're going to use. So if we just say new position.y, new position.x, then all of our red lines have gone away, and this is code that will compile. But we've moved our Z position. So okay. We can see that it's not quite running quite right yet, and the reason for that is we've forgotten something. Basically, we're setting new position to this this zeroed out value here. So what this is basically saying here is, we're determining our new position, we're setting ourselves to the new position, but it's always this 0 value. And part of the problem is that if we, preview what this looks like, we determined earlier that if our Z is at 0, we're going to be behind the grass. So essentially an easy way of dealing with this is if we just move the grass back a little bit. And, there's other ways to get around this problem, but this will help us. This is the fastest and it's the easiest for now. And so now, based on this, we can see that the player can move around a little bit, but the problem that we're running into now is if we click on the player here, we can see when we're holding A, we're going to the left, we're just set to -1, and we're not moving beyond that. Similarly, to the right, we're going +1, up or down, depending on what we're doing with W or S. And the reason for that is basically, if we look at this code, we're setting ourselves to 0, 0, 0 here. And then, if we say we're holding up, then we're setting ourselves to 0, 1, 0. And then this is our value, and we're setting that at the end here. But then the problem is, this function runs 60 times a frame. So when it comes in the next time, it's still saying start at 0. What we really want to do is start at wherever the player is and offset them that 1 every frame. So the way we do that is, instead of looking for vector3.0, we simply say whatever the position is right now. If we were to look at Unity, 0, 0, 0, or let's say that they're somewhere else over here. Next frame we want to offset ourselves here, and then here, and then here, and then here. But it means that when we start here, we need to use this value as the starting point and not this 0 value. So if we compile that, now we can see that we move around, we move very quickly. So perhaps we want to not use quite such a big number. Usually something more like this is 0.1 is better, just because Unity units are so small. But even this, there's much better ways of doing this, which we'll get into. For now, we can see our character can kind of move around. We can see it's a little bit jerky, it's a little bit like inconsistent, it doesn't really feel the greatest. So we'll fix up some of that later. But for now, you know, we've got some very basic player movement working. We've got a basis that we can start building on. And in the next lesson, like I said, we'll clean up some of this movement stuff so it's a little bit more elegant, and we'll start looking at our tools and all the other things that we need in order to make our little farming game. So hopefully this has been instructive, and yeah, check out those future episodes for more. And yeah, I guess if you've enjoyed this, if you've learned something, then feel free to drop a like and subscribe, and see you next time.